All right, in this video I'm going to be doing a couple of the practice problems from the recent sheet that I had put up, which had, at the very end, there were some problems on balancing in acidic and basic conditions. So I'm going to do one of each of those ones there. So let's start with looking at one where we are in acidic solution. Now keep in mind, like, the overall process is still going to be the same. Okay? So the first thing is to get our oxidation numbers. And just a little abbreviation there. Oxidation numbers is number 1. Okay. So first off, let's take a look at what we have here. Now, oxygens, again, they are fairly consistent. So let's start with that. That's nice and easy. And it's minus 2. It's not a 2. Let's try that again. Minus 2, okay? And there are 7 of them, so the total negative charge is minus 14. Now with that, looking through my work here, I don't want to make a mistake. It's very easy to, as you probably have learned, to make a little mistake here. Okay? Now, with chromium, the Cr there's 2 of them. So the total positive charge has to be plus 12. Because this molecule here has a charge of 2 minus. Okay, so that means the total charge then has to add up to negative 2. And so to get that, chromium would have to have a total of positive 12. And what we should also notice here is that there are 2 chromiums attached to the oxygens. So each of those have to be plus 6. Okay? Next one, let's take a look at the oxygen there. Again, that's going to be minus 2. We got 3 of them, so the total charge is negative 6. In this case, the charge is again negative 2 there. So the total charge should have to add up to negative 2. Therefore, sulfur, I should say, must be plus 4. Okay? Now let's go on to the other side. This first chromium is fairly straightforward. It's just going to be plus 3 based on that there. That's a nice and easy one. Okay? And then when we look over at the sulfate there, SO4, we get that again. Oxygen is 2 minus. We have 4 of them, so the total is negative 8. The charge on here is negative 2. And so this sulfur must be plus 6. Okay? Because in this case it should add up to negative 2. Now based upon this, okay, second thing we need to do, let's look at this, and which is oxidation and which is reduction. So let's take a look here. The one important thing also I should just mention here at this point is make sure you are basing which one gets reduced and oxidized off the individual atoms, not these total ones up here. That's just to help figure out what the individual ones are. So in determining which one has been oxidized and which one has been reduced, make sure you are basing it off the individual atoms and not the total charge there. Okay? In this situation, it doesn't actually really matter here because it works out the same way. But in some instances, the total might be higher and it may look like something is being oxidized, but when you take it at the individual level, it's actually the opposite. Okay? So let's look here. We got chromium, which is going from plus 6 to plus 3. Okay, so that is becoming more negative. This one is being reduced. Okay. Now, after that, let's take a look at sulfur because oxygen stays the same throughout. So sulfur goes from plus 4 to plus 6. Oops, it's a little off there. We're going from plus 4 to plus 6. So that's becoming more positive, and then therefore this would be oxidized. Okay, so now that we have that, our next step is to do half reactions. I'm just abbreviating reactions as RXN, just because. Okay. Now, this is going a little bit ahead, but otherwise we're going to be losing our work here. After that, we are going to balance electrons. Okay. And then we will, actually, sorry, whoops, this is for acid. We are going to balance oxygens first. My mistake. Balance the oxygens and hydrogens. Then we do balance electrons. And then combine. Okay, so those are our goals here and where we need to get to. So next, let's move on to the third step here of writing a half reaction. All right, so here we go, oxidation. And this is why I had my workout here, because now I lost that equation. So we had for oxidation, we had sulfite, SO3, 2 minus, becoming sulfate, SO4, 2 minus. Okay, and with this, we need to add in waters to balance out the oxygen, because if you look at it, there's no way in this possible scenario for us to balance by inspection, which is just adding in the coefficients. Second, you add in a 2 to the sulfate here, you've also changed the sulfur, and you get into an infinite loop, so it won't work. So this is where oxidation and redox kind of has to come into play. Okay, so let's start by balancing this guy out. We have 4 oxygens on the right side. We need a total of 4 on the left, and we can simply do this by factoring in a water molecule. Okay, H2O. Now, because we have done that, we also have to add hydrogens to the other side, so we do H plus. Oops, not 2 plus, just plus. But we would have 2 of them. My mistake. 2 of them like that. Right? Now at this point we can figure out then the number of electrons that had to be added in. And for this guy, with oxidation, we would need, there would be 2 electrons being ejected here, sent out. And that is consistent with the oxidation numbers that we had, where it went from +4 to +6. Okay, so we've lost 2. Reduction, on the other hand, is going to be, we'll take a look here, we had that Cr2O7 minus becoming just Cr3+. Now the oxygens again are missing, so let's add them in. And so we would need, first off, we need 7 H2Os, okay? And that means then on the other side we need 14 hydrogens being added to this. Okay, and the last thing now is the electrons. So we went from +6 to +3, that means we had to have 3 electrons come in here. So that would give us 3 electrons, trying to fit that in there. My mistake. Or not really a mistake, just a little squish, sorry. Okay. Now, with this, we need to now balance out our electrons. Okay, and so to do this, we are going to, oh, actually, sorry, you know what, I did make a mistake here. It's not 3 electrons, it's 6. And one thing I did miss here at the start is that there should be 2 CRs, because we had 2 on this side. Okay, so technically each of these guys here are going to be gaining 3 electrons to make this. So this part here is happening twice. So we do actually have to double the number of electrons. So it's actually 6 to make this happen. Sorry about that. Okay. So now when we balance out our electrons, all we really need to do now is multiply this top oxidation equation by 3. Okay, multiply by 3. And what we should end up with now is 3H2O plus 3 sulfite yields 3 sulfate, 6 hydrogens, and 6 electrons. Okay. And now at this point, our last thing that we are going to need to do is combine these. So what can we cancel out here? So the electrons are balanced. We get rid of those. Now we have hydrogen showing up on both sides, so they are going to cancel out. Now obviously on this side, those are unnecessary. So we have a net of 8 hydrogens, and we also have an excess of water. So we don't need those guys, and we're left with 4 waters. Okay? And now that we've done that, let's combine this all into one equation. And again, it doesn't actually matter which order you go in, so I'm just going to go left to right, what I see first. So we have 8 hydrogens plus Cr2O7. That's chromium something oxide plus 3 sulfites yield 2 chromium ions plus 3 sulfates, and my picture's in the way. I'm going to write this a little bit lower because otherwise my camera part's in the way. Actually, I'll write it up here. Plus 3 sulfates plus 4 H2O. Okay, now this is our balanced equation, and everything here is good. Okay, so that one is complete. Okay, so let's take a look now at a different one where we are balancing a base. Okay, now let's take a look at an example where we are balancing in a basic solution. So we got this bromide ion, which is reacting with MnO4 to become MnO2 and BrO3, which is bromate. Okay, so first off, oxidation numbers. Let's start off at the top here. We got -1. Oxygen is -2. 4 of them, so it's -8. But of course, there is this negative charge here, so the total thing has to add up to -1. So this must be +7. Okay. Next, let's go on to the other side. We have oxygen, which is -2. I'll even just throw that in there right now for now. So our total charge is -4. Therefore, manganese must be +4. Okay. Bromine, on the other hand, in this BrO3, okay, it has a total negative charge of -6, and we have a -1 charge on this molecule, so the total must add up to -1. So that means this bromine must be +5. Okay, so we got our oxidation numbers. Now, which is being reduced, which is being oxidized. So we got Br going from -1 to +5. Okay, that is obviously becoming more positive, so this one is oxidation. And then we have manganese going from +7 to +4, so this would be reduction. Okay. Next, our goal is to then write the half reaction. So let's do that on the next page here. Okay. So with oxidation, we had bromine becoming BrO3. Now those oxygens obviously can't come from nowhere, so let's now balance this. But the key thing here to remember is that with a basic solution, we're using OH, hydroxide, to balance the oxygens and water to balance the hydrogens. Okay? And you will generally find it easier to double the amount of hydroxides you need right off the bat. Okay, so let's first write in that we have 3 oxygens here. So again, we would need 3 hydroxides, but again, easier to double it, makes less work in the long run. So let's just do that. We have 6 hydroxides here. Okay. On the other hand, that means we need 3 waters on the right side. Okay, and now this is more or less good. That balances both the oxygens and the hydrogens. We got 6 and 6. We also went from a +1 charge to a +5 charge on bromine. So that means 6 electrons were released here. Okay. Now, on the reduction hand side, I should say, we have MnO4 with a minus charge becoming MnO2. Right? Now, so Mn's are balanced, so we don't have to do anything there like we did with chromium in the previous example, so we can go straight now to oxygens. So in this case, we're missing 2, so let's add in 4 hydroxides. Okay, so 4 OH. That means then on the left side, we would have needed 2 water molecules. Okay. So now our oxygens are balanced, our hydrogens are balanced. So now let's take a look at the electrons. Okay, this MnO4 became MnO2, but the oxidation change was +7 to +4. So that means 3 electrons were required to do this. Okay, so now we have to balance the electrons, and this one works quite nicely where we have 3 and 6. So we don't have to do anything to oxidation, but we do got to multiply this reduction by 2. So we get 6 electrons, 4 waters, 2 MnO4 minus 2 MnO2 and 8 hydroxides. Okay, and now we can begin canceling things out. So electrons obviously can be gone. I mean, it's not that they're not there doing anything, it's just it's the same on both sides. So not really all that necessary to write it in both cases. Okay. Waters, we had 3 of them on the right side, but we had 4 here. So there's a net use of 1 water. And then with hydroxides, we had 6 over here, and that'll make this then into a 2. Okay. So that's done now in terms of canceling out. So let's just combine it into a complete balanced equation. Again, the order does not matter. So we have H2O plus 2 MnO4 minus plus Br minus. Okay. And we get 2 MnO2 plus BrO3 minus, and those 2 hydroxides at the end. Okay, and that is balancing in a basic solution. And so everything's good there now. So if you have any questions, feel free to let me know. I can do a couple more if you need some time. But at this point, everything is good at this for these 2 here. So if you need some more, take a look at the other practice ones and let me know if you need some help solving them, and I can definitely help you out with that. Hope this made sense, and again, let me know if you have any other questions about them.